Hello everyone, I'm Abhishri A of Sri Venkateshwara College of Engineering and today's topic is Introduction to Static Hashing. Introduction to Static Hashing. Static hashing is a technique used in computer science to organize and retrieve data efficiently. It involves dividing the data into fixed size blocks and assigning each block a unique identifier or hash value. The hash value is used as an index to store and access the data in the predefined data structure called as hash table. Benefits of static hashing. Static hashing provides fast and constant time access to data. It allows for efficient insertion, deletion, and retrieval operations. Static hashing is suitable for applications with a fixed and known set of data. Components of static hashing. Hash table, the main data structure used in static hashing, which consists of an array fixed size slots or buckets. Hash function, a mathematical function that converts a key or data item into a hash value or index. Collision resolution, techniques used to handle situations where two or more data items have the same hash value. Example, we'll take the example of a student record here. So let us consider a scenario where we have a database of student records with attributes such as student ID, name, and grade. We can use static hashing to organize and retrieve these records efficiently. Each student record can be assigned a unique student ID, which will serve as the hash value or index. Hash function. Example for a hash function. Suppose we have a simple hash function that takes the student ID and performs a modulo operation with the size of hash table. For example, if our hash table has 10 slots, the hash function HID equals to ID modulus 10 will map each student ID to value between 0 to 9. Create the hash table. To create the hash table, we initialize an array with a fixed number of slots. In this case, each slot represents a bucket that can store one or more student records. Initially, all slots are empty. Inserting a student record. To insert a student record into the hash table, we calculate the hash value using the hash function. We then place the record in the corresponding slot or bucket of the hash table. If there is a collision, we use a collision resolution technique to handle it. Retrieving a student record. To retrieve a student record, we calculate the hash value using the hash function based on the student ID. We then access the corresponding slot or bucket of the hash table to retrieve the record. If there are multiple records in a slot, we can use additional keys or attributes to narrow down the search. Deleting a student record. To delete a student record, we calculate this hash value based on the student ID using the hash function. We then locate the record in corresponding slot or bucket of the hash table and remove it. If there are multiple records in the slot, we may need to use additional keys or attributes to identify the correct record. Collision resolution techniques, that's called chaining. Chaining is a common collision resolution technique used in static hashing. In chaining, each slot or bucket of the hash table contains a linked list or another data structure to store multiple records with the same hash value. When a collision occurs, the new record is added to the linked list in the corresponding slot. Collision resolution techniques. Open addressing. Open addressing is another collision resolution technique used in static hashing. In open addressing, when a collision occurs, we search for the next available slot in the hash table to store the record. Various methods like linear probing, quadratic probing, or double hashing can be used to find the next available slot. Example chaining. Continuing with the student record example, let's assume two students records having the same hash value and need to be stored in the same slot. We can use chaining to handle this collision by creating a linked list in a slot and adding the records to it. Example of open addressing. Alternatively, we can use open addressing to handle the collision. In this case, if there is a collision, we search for the next available slot in the hash table to store the record. We continue this process until an empty slot is found. Pros and cons of static hashing. Pros: fast and constant time access to data, efficient insertion, deletion, and retrieval operations. Static hashing versus dynamic hashing. Static hashing is different from dynamic hashing, where the size of the hash table can change dynamically as data is inserted or deleted. Dynamic hashing provides more flexibility and efficient memory utilization compared to static hashing. However, static hashing can be simpler to implement and may be preferred for application with a fixed and known dataset. Use cases of static hashing. Static hashing is commonly used in scenarios where the dataset is known and does not change frequently. Example includes storing configuration data with fixed properties. Conclusion: static hashing is an efficient technique for organizing and retrieving data in computer science. It involves dividing the data into fixed size blocks and assigning each block a unique hash value. Static hashing provides fast and constant time access to data, making it suitable for applications with fixed and known data sets.